Hi, my name is Dean, and today I'll be talking about the Mannich reaction. The Mannich reaction was founded in 1912 by Carl Mannich. He taught pharmaceutical chemistry and was a professor at the University of Berlin. So a quick overview how the reaction works. The Mannich reaction first begins with the formation of an electrophilic aminium ion produced by formaldehyde with a primary or secondary amine. Next, due to the acidic conditions, an enol is formed from the added aldehyde or ketone. Finally, the enol reacts with the aminium ion to produce a beta-aminocarbonyl. The first part of this reaction involves formation of an aminium through the addition of the secondary amine to formaldehyde and then the loss of water. It is important to note a non-enolizable starting material was used, such as formaldehyde, to prevent the synthesis of an enamine instead of an aminium. In the second step, an aldol-type reaction takes place, with the enol attacking the electrophilic carbon, producing a beta-aminocarbonyl. Within the chosen literature, the Mannich reaction uses an oxyndole as the nucleophile after the aminium is formed to produce the beta-aminocarbonyl. An oxyndole is a bicyclic structure consisting of a 6-membered ring fused to a 5-membered nitrogen-containing ring. The oxyndole is unique since it has a carbonyl in the second position of the 5-membered ring. There are 3 separate groups of reactions within this procedure. The first group modified the solvent, the second group modified the R groups, and the last group of reactions modified the choice of amine. For stereochemistry purposes, we'll be looking at the first group of reactions since the reactant stayed constant. Through the use of several solvents, we see the target molecule stayed consistent with different yields being produced. The final product contains a point of chirality at the third carbon on the 5-membered ring. The point of chirality formed an R configuration, and replacing either group gives an anchoris. In the second set of reactions, the backbone of the nucleophile stayed consistent with only the R groups being manipulated. Overall, this gave the best set of percent yields. For the final set of reactions, manipulation of the amine being used gave a variety of percent yields. There is a common trend that the more bulky the amine was, the less product occurred. This reaction has a lot of application in the synthetic universe. First, it has a large amount of reactants that can be manipulated. For example, an oxyndole or enol can be used as a nucleophile to attack an amine or aminium, producing a large variety of products. It also forms a new carbon-carbon bond and adds an additional functional group into the molecule, which can be further reacted upon. Finally, this last reaction was interesting since the target molecule is the tricyclic beta-aminocarbonyl. The first step involves unmasking of the acetyl protective group due to the acidic conditions to expose the aldehyde. The carbonyl in the aldehyde is electrophilic, which will form an aminium with the nitrogen due to it being 6 atoms away. The second step involves an enol being formed and attacking the electrophilic aminium intramolecularly to give the final product. Thank you for listening.